Hey gang, this is Mr. Schmidt. I'm here for going over the questions that came up during class on this next assignment, the balanced and unbalanced forces. So what I'm going to do is going to go over questions 1, 2, 7, and 9. Okay, so if we switch over to over here. All right, so question 1 was saying the amount of forces. So once again, let's make sure we have our units correct. These are the units of newtons. So if we change any of these units, we no longer get units. So let's make sure we have that correct. Okay. So they give you in the question a couple of key facts here. So the amount of force keeping 6 kilograms is our mass. Our velocity is 2 meters per second, but then they say something very interesting and very important, and that is a constant velocity. Okay, why is that so important? So that means our change in velocity equals 0, which means our acceleration equals 0, which means our force or our sum of our forces equals 0. Okay, so if we have a constant velocity, we have no change in velocity, we have no acceleration, we have 0 total force. Okay, so that means force is not required to keep an object in motion. Okay, in fact, we could say an object in motion remains in motion in a straight line unless acted upon by an outside force. So we don't have to do any math. We don't have to go on to the Newton's second law whatsoever because we know this is 0. Okay, so that was number 1. Number 2 gave us some different dots here. Okay, so let's get over here with the right marker. All right, so what we're going to look at is a bunch of dots here. So if the dots are close together, that's low velocity, and then the velocity starts getting bigger. Okay, so if we're having this small velocity to high velocity, then yeah, we have unbalanced forces. Okay, so this one does not equal 0. Okay, now if we have them all equally spaced, okay, and they do a much better job drawing the equal spacing than we do, then yes, the sum of the forces does equal 0. Okay, so this is unbalanced, these are balanced forces. And what happens if we go from fast to slow? Okay, well, that means it was slowed down, and this is an unbalanced force. So speeding up, unbalanced, slowing down, unbalanced, constant velocity, balanced forces. Okay, so there's 1, there's 2. The next ones people asked about were 7 and 9. Okay. 7, during a class discussion, Analytica, which I hope you appreciate those names, Analytica suggests to our lab partner that the dot diagram for motion in 6b could be. So first of all, let's make sure we know what 6b was. 6b looked like this, and then we had force equals 20 newtons, and this force equals 20 newtons. Okay, so these two are equal. So we know the sum of our forces in the y equals 0, and there's no forces in the x. Okay, so that means an object in motion is going to remain in motion in a straight line. Okay, there's no outside forces. Okay, so the question is, could we have this as our path? Yes, you could have the motion going like this. Okay, by the way, you could have also had that. That would have been acceptable, right? That would have been feasible. Okay, you could have also had, what are we saying? An object in motion can remain in motion in a straight line. Okay, so that is all possibilities. What would not be possible Okay, so what would not be possible would be anything that's not a straight line. Okay, those are not possible because they're not in a straight line. Okay, also not possible would be anything that is slowing down or speeding up. Okay, conceivably, we could have also just had, okay, it keeps staying at the same place over and over again. So that's kind of the base assumption, but all of these are possible. So keep that in mind. Okay, so that is number 7. Analytica was right because any straight line constant motion is possible. Okay, and then number 9 is a great one because that is kind of a trick question. Okay, let me see if I can get to a blank piece of paper here. There we go. Okay, number 9 is a great one because they're asking you what is the magnitude and direction of the forces acting upon an object, which object could be moving to the right. Okay, so they give us 5 boxes here. Okay, those are our boxes. We have one that looks pretty balanced. Looks like the sum of the forces equals 0. This one looks like the sum of the forces equals 0. This one looks like the sum of the forces in the x equals some number. Okay. This one looks like sum of the forces in the x equals some negative number. Okay, this is some positive number. And then this one looks like this magnitude is greater than this one, so the sum of our forces in the x, again, is some negative number. So if all of that's true, then what does that say about motion? Could this be moving in a straight line at a constant speed? Yes. Can that one be moving in a straight line at a constant speed? Yes. How about this one? Can that be moving in this direction and with a positive acceleration? Yeah. Can this one be moving to the right with a negative acceleration, meaning it's slowing down? Also true. Can this one be moving to the right and slowing down? Yes. So your answer, when I say circle all that apply, okay, all of those can be moving to the right. Okay, they might be constant or speeding up or slowing down, but they can all be moving to the right. Okay, so those are the examples. I'll take any more questions on Wednesday, and then we'll get ready for our pumpkin drop as our next project. Okay, and with that, everybody, have a good day.